I'm here to talk to you about data historians. I've got two versions of this talk under development. I would call this one the smooth jazz version. If you want to see more of a nu metal version coming your way in June. But let's be honest, sensor data kind of reads like a teenage diary. It's emotional, it's disorganized, it's full of noise, and it's really hard to interpret unless you were there. In the context of oil and gas operations, even the most stable operations have chaos. Valves are twitching, pumps are surging, compressors are coughing. It's all in the data, but you don't know where to look. This talk is about turning that mess into something you can understand and something you can use. We'll have a look at how data historians help us move from scattered, time-stamped chaos to insight you can act on. So first, a little bit about me. My name is Shane Chidla. I'm a professional geologist. I entered the industry almost 30 years ago. So probably I've been working at this for longer than some of you have been around, but that's okay. I've worked mostly in the Western Canadian Sedimentary Basin, which is what we geologists refer to as the subsurface within Western Canada. So there's Alberta all the way to actually southwestern Manitoba is included in that. I've actually also worked a couple of basins in South America and conducted field work throughout Canada and the US. So during my oil and gas career, I've worked at a couple of different operators. I've worked on every sort of workflow that geoscientists can be involved in. I've worked in exploration, exploitation, acquisitions, divestitures, investor relations, marketing, you name it, I've worked on it. And I've worked just about every asset that you can north of the 49th parallel. When you're a geoscientist, you encounter data pretty much in every aspect of your work. It's everywhere. And you really notice, especially when I was getting started nearly 30 years ago, that data is not well connected. You're always looking over here for your well logs, over there for your geoscience, your geophysical data. I had engineers pulling SCADA data, yes, even way back then. Production reports, lease ops reports, which is a type of financial report. Land files, all kinds of information that it was my job to try and pull together to try and tell a story to management to convince them to do what? Give me money so that I could drill a well and prove my theory and hopefully extract hydrocarbons from the ground and improve the company, society, being able to use our energy to build things and do things. When you're a geologist, you don't work in a silo. Almost always you're on an interdisciplinary team that includes engineers, finance people, land negotiators. They all have their workflows, their information that they need to make decisions. And pretty quickly you try to figure out what it is that makes those workers or those leaders that you're trying to convince, what makes them make decisions, what is the lack of information that prevents them from making decisions. How can you fill those gaps so you can move those decisions in the direction that you want? So I found myself often translating between different roles, talking to finance people and making that something that engineers could understand. That's why I've got up here a career in translation, more so than a transition. It made me very curious. And that led to questions about the systems, the access, the visibility, the lack of connectivity. What can we do about this? That's when data analytics and digital transformation entered my life and my toolkit. And then that evolved. I eventually found myself leading a team that was entirely focused on data analytics, which might seem kind of unusual for a geologist, but there's actually quite a few of us with technical backgrounds that this is where we ended up. Was leading one of these, again, multidisciplinary teams. So I found myself asking, why can't we get all this in one place? Well, be careful what you ask. Because pretty soon, you're the one trying to make that one place happen. So why do data historians matter? Well, we got on our left-hand side here, what it's like without a historian, and then on the right, what it is like with a historian. So without a historian, You have sensor data coming in, but it's a disorganized mess, like I said earlier. We've got tons of sensor data, no structure. We've got alarm chaos or alarm fatigue. We've got alarms coming from multiple systems, and each person working with those alarms, you know, they've got alarm over here, we got to go to that system. We've got alarm over here, we got to go to that system and figure out what's going on. It can really create a lot of chaos that way. And then we also have decisions being made based on people's memory instead of being data-driven. You might see a lot of manual spreadsheets, which is actually pretty common still today. And then you end up with frustrated users. No one trusts the data. Maybe they even ignore it. With a historian in place, the data is organized, it's searchable, it's time-stamped, and we can use it. Operators can trend values over time. Engineers can troubleshoot without guessing. And analysts that are working with the data can start building interfaces that help leadership make decisions. They get that holy grail that we're always looking for, the source of the truth. A historian doesn't just collect data. It gives the data context, it makes it trustworthy, and it helps bring it longevity. So here's a little bit of today's agenda. We're going to cover what is a data historian and probably more importantly what it isn't, how the sensor data flows through different systems, who uses a historian and what they do with it, best practices for implementation and usability, and then I've got a couple of real examples that we've worked on at Corality. And then I'm finally going to tie it back to you. Why does this matter to you? So starting with what is a data historian? So it's not a person. I know that's what I thought the first time I heard about data historians, and full disclosure, I don't think I'd actually worked with them or heard of them until I came to Corality. So this is something that's pretty new to me too. But it's a database. It's built for a specific kind of data, a data that I do have a lot of experience and frustration with trying to work with in my previous career, and that is continuous time-stamped data from machines and sensors, sometimes called time series data. You can think of it a little bit like a Fitbit or a black box. If you've got one of these guys, you already know what a sensor feels like and what a historian feels like. In my case, my Apple Watch is tracking my heart rate, my oxygen, my sleep. I mean, I use this thing for almost everything. But all of that is searchable, and I can go back in my history and see, well, was I sleeping good when this happened or not? When we get to my age, that kind of becomes something you're looking into a lot. The difference is in oil and gas, the body is a well site or a pipeline or a facility, and there might be thousands of sensors that the data is being collected from. A historian is optimized to store a lot of data and to store it fast and to store it continuously with historical traceability. You'll find them anywhere that has complex equipment that needs a record of how things behaved over time. And unlike an SQL database that's designed for transactional data and business reports, historians are purpose-built for time series data that is constantly changing, and sometimes every second, depending on the system. So a little thought experiment. You pick up someone's phone, you see a big red badge, the number 50. That's all you know. There's 50 messages. What's going on? You don't have any context that tells you what those messages are about. Is it 6 different apps? Is it one app? Is this a breakup? Is it a group project? Are we ordering pizza? What's going on? I don't know. The timestamps are there, but it's not structured and we have no context, so we can't figure it out. Without that context, you're basically just picking up someone's phone and you might be reading out loud just what it says on their notification screen. It's not very helpful. Scale that up to hundreds of devices across a facility, sending different signals at different times through different applications, and you can get a sense of how things can go sideways. So just in summary, what is a data historian and what it is not? People often confuse historians with just another database, and that's not what they are. It's built for time series data that's coming in constantly, like pressure, temperature, vibration. It's designed to interface with SCADA systems and run fast, especially for ingestion. And it's not for general purpose storage. It's not SQL or Excel. You wouldn't use it for financial reporting or for customer data. And it's something to keep in mind, it's not especially user-friendly out of the box. You do need some experience, some expert context provision to help you set it up the most optimal way. The source of all this data is physical equipment in the field. So we start with the sensors. This is just a picture of some different types of sensors, but they might be installed on a pressure valve, might be installed on a wellhead, maybe a blender at a well site or a storage tank, some components of a facility, things like that. And in our context in oil and gas, it mostly is measuring pressure, temperature, volume. It might measure fluid content, vibration, things of that nature. So the sensor detects what's going on and sends that information into a PLC sometimes before it goes into a SCADA system. So what are those things? A PLC is a programmable logic controller. It's a special kind of computer that takes that sensor information and it might, based on some programmed logic, execute some controls. After the data passes through that PLC, it might go on to a SCADA system, which stands for Supervisory Control and Data Acquisition. So this is also a system that operators might look at. And they might use it to control and monitor what's going on in the field. So that all happens. Then the data lands in a data historian. The historian is where we store the data, and it stays organized, structured, and accessible. And then from the historian, this is the part where things can get really complicated. We take that data and move it into some kind of interface so that leadership, analysts, people trying to understand what's happened, maybe they're doing a root cause analysis, can have some kind of visualization of what's happened. So this could be dashboards, alarm systems, analytics, data feeds, calculations, you name it. So who's going to use a historian and what are they going to do with it? So historians can be used in multiple industries. I've listed, this is by no means an exhaustive list, but oil and gas, of course, manufacturing, food and beverage, water treatment, power and utilities, the mining industry, pretty much anywhere where there's equipment that has things like pressure, temperature, vibration, monitoring, you might have a data historian connected to that. Because our experience is mostly oil and gas, that's what I'm going to dive into a little bit. And so in a typical oil and gas company, you might have these roles. And each of these roles could interact with data from a historian. They might not even know it. So an operator in the field might be monitoring data from a historian to respond to alarms, monitor trends, keep an eye on things in the field. An engineer, and I'm thinking in this case like an office engineer, production engineer, and operations engineer, might look at data in an interface to troubleshoot, do some root cause analysis of something maybe happened. There was a leak or some equipment failed. They're trying to understand what happened so that they can try and prevent that from happening again. Analysts, so myself, maybe some of yourselves, would be working with that data to build dashboards, KPIs, those kinds of things to help anyone else who's working with this data be able to gain the insights they're looking for. And then of course leadership, they're looking at very high level things like KPIs, validating compliance, and trying to support decisions they're making. Of course, we can't forget the IT and digital teams. They keep it running, they keep it secure, and they keep it connected so that all the systems continue to talk to each other. So some of the issues that can be encountered when you're implementing these systems. One of the biggest ones that we've encountered is, I use the word bad or inconsistent tag naming. Well, it's so easy for this to happen. For example, let's say we have a tag on a piece of data, and the tag is just PV 101 or something like that. What does PV stand for? That's a good guess. That's actually one of my possibilities I have on the list here. It could also mean power voltage. I can think of a few things that PV stands for. If it's not clear to me what it means, what am I going to do? Probably one of two things. I'm going to ignore it, or I'm going to make up my own tag. And now we've got two tags that mean the same thing. And that's just a minimum, right? If everybody did that, pretty soon we've got 20 or 30 tags that mean the same thing. Names matter. Don't make people guess what they're looking at. That leads to multiple tags for the same thing. One of the ways that we've found really successful to deal with this is something that we call an asset hierarchy. So it's really just a way of organizing your tags so that when you're developing a name, it follows a system that anyone can learn, and then it helps them understand what each tag means, and then that helps prevent the creation of additional tags. And then our favorite issue, how many times have we heard garbage in, garbage out? Well, just to put a little bit more positive spin on that, how about clean data in means clean analysis out? So trying to tune the data at the edges before it comes into the system is always ideal. But if you can't do that, you do always have exceptions. The goal is to try and get it as clean as possible in the source before it's coming into the integration that you're building. And one of the most important things that is, again, I feel like this is repeated in just about any project context, is working with and collaborating with the people who will be using the information at the end. Tools only help if people can understand and see value in what you've built for them. Talk to the users early, not after you've already gone live with something. So now we've got a bit of an example. This is a real world case that we dealt with. We had a client with millions of completion related tags that were completely inconsistent. And I don't know how easy it is for you guys at the back to see this list here, but just about all of these items have some version of the word pressure in them. So my personal favorite at the bottom is Purser. And you can see, these are all kind of free-form created probably, so you can see how, we've got a bunch of different tags that might mean the same thing. And our little animation here, I'm just going to restart it here because we started with just one little node, and pretty soon you see what happens when it's all disorganized. I can't make out how any of that connects to each other in this network. And important to note is this is not unusual. This is pretty much the default for systems that have been put in place in legacy operators. And it creates a huge missed opportunity for optimization and automation. And it seems like a really simple problem. It's easy to understand, the core issue is defined, and the solution seems pretty easy, just clean that up. Well, it's not that straightforward. Retroactive standardization is really difficult. You've got multiple stakeholders, they all have their own opinions about what's important, and sometimes those opinions conflict. Different systems use different tag structures. Mapping challenges can come into play, and even with machine learning approaches and rule-based methods, like I was saying, you end up with edge cases that don't fit into your algorithm. So you always have to deal with that, and that's what can take a lot of time. And in this case, I'm going to show a little more detail on this, but we started with the root issue, which was inconsistent tag naming, by developing a classification system to filter and normalize the tags. But I've got a little more detail about that. So how do we solve this? This looks complicated. It's fun. This is a little bit of theoretical math. This is a model from network theory that helps explain how some systems are more connected than they look. In a historian, we often treat each tag as a standalone stream, but tags are linked. Sometimes they're linked by equipment or process or by time or all of the above. This kind of model, which is for those of us a little more experienced in the room, it's the 6 degrees of Kevin Bacon theory, that every movie star is connected within 6 degrees of Kevin Bacon. We can apply the same logic here. If we structure the data right and preserve relationships, we can start detecting emergent behavior, not just individual values. So yes, this looks like theoretical math, but it actually has a real application. So this is that example I was talking about earlier, where we started with the tag naming and trying to apply some logic to that. So what we did is we applied this concept of a asset hierarchy and broke down the tags into different levels. So what we started with is what we called the tiers. We've got 5 tiers of tags here. So tier 1 is a parameter type and the location if possible. And then in the tier 2, we've got what are we measuring? What is the parameter that we're measuring? So tier 2 is things like pressure, concentration, rate, volume, level, time, and mass. And then we start connecting those together over here, where we've got tier 1 and tier 2 gets put together, so annulus pressure. So now that makes sense. Annulus pressure. You go through and retroactively standardize all your tags. We're good to go. Are we good to go? Probably not, because now we're going to keep moving forward. How do we keep that mess from happening again? So what we did was we developed an app, custom app for our client to keep this a living system. So someone can go into this app and look at all these different types of pressure that we have and do some searches and find tags that already exist. And I think this app also allows users to make new tags if they really can't find the perfect, the holy grail tag they need for what they're looking at. The other thing that we did in this case, and this took some time as well, was working with the client to determine how many tags were really needed. How many of those parameters for tier 2 did we really need? In this case, I think we have 7. So, at different levels, it's a different number, but how many do you really need to describe absolutely every combination that you could have? I think in this case, it's 7 times the number of locations. You end up with hundreds of thousands, maybe thousands of tags, versus many systems that you might encounter have millions of tags. So that's a sign that you've got a proliferation problem if you're at millions of tags instead of hundreds of thousands. So at the end of the day, this client was able to go from disconnected noise that didn't make much sense to something that was structured, something that was ready for analytics. And this was a key for them to move ahead with using their historian data to generate insights. This is the same data, and it's reorganized. And what you can see is we've got now a little node in the center here, and then you can see those tiers growing out from the center. And now we can see how everything is connected. And now it's starting to make sense. I know I feel a lot less anxiety looking at this than looking at the other diagram. And here's just a couple of other examples that we've worked with that use historian data. So on the left-hand side here, we've got an example of, this is an Axiom dashboard. Axiom is a visualization tool by Canary, which makes one of the historians that we work with. So they've got their own visualization tool that you can put on top of their data. You could use a different visualization tool, but in this case, we've used Axiom. But what you can see here is there's a lot of things that you would be familiar with in other data applications. We've got a data architecture diagram that shows how all the data comes together, and then we've put something together for the client to use. This is just a simplified view of all the location data for that client. And then on the right-hand side is just another use case where we set up an automated alarm system for casing pressure, where we're leveraging sensor data to notify the client when departure pressures are exceeded. So what you can see here is the user can go in here and set a departure pressure that they want an alarm at, and then their alarms are generated below. Okay, so here's a few publications that we've generated over the years that relate to actually all 3 of those use cases. So if you want some more detail about any of those cases that I talked about, you can actually just scan this QR code. It goes to our website, and we have a publications page there where you can find links to these publications as well. So some final thoughts. Industrial systems generate sensor data every second. It's only useful if it's captured and structured and accessible. A historian isn't just a database, it's operational memory. If people don't trust what's in there, they'll go back to guessing, or the worst of all things, exporting to Excel. It's not enough to collect the data. You need to structure it so people can actually use it. Usability matters. If it's clunky, people will avoid it. If it's accessible and makes sense, it becomes part of their workflow. You have to work with the users. This is a really common theme I hear just about every talk I go to. Not just the people implementing the system. It's really important that the users have input on how you set up your visualizations, your key KPIs, how the data flows in a way that makes sense to them and to the business. At the end of the day, more data doesn't mean better insight. Context is what makes the data useful. If you can connect the sensor to the strategy, you're going to make a difference. Bridging the gap between IT, OT, and the business is a skill that's in high demand. Good data isn't just collected, it's engineered and structured and trusted. You could be the people that make that happen. So this is going to sound really like strange advice, but learn a language or learn to play an instrument, anything like that. You can pretty quickly understand, like myself, I'm a classically trained piano player. I was trained when I was young. And one of the things that I really worried about when I was pivoting was you can't teach an old dog new tricks, right? I'm an old dog now, how am I going to learn new tricks? And one of the things I decided I would try and do is learn to play a new instrument that I didn't know how to play. And the reason this was relevant to me is because I already knew a lot about music. I knew how to read music, I knew what good music sounds like, I know how instruments should sound together, how they should all work together. I just only know how to play one instrument. So if I learned something else, could I prove to myself that I had that capability? And I was successful. I learned to play another instrument when I was 47 years old, and I didn't think I would ever be able to do that. And that encouraged me, that I felt like I had the brain power and the experience that I had would help me put context to the data. And it was the same with learning an instrument. If I'm just learning an instrument and I had no background in music, I have no context. So I'd have to spend a lot of time learning that. I didn't have to learn that. So I would just encourage you to think about the other aspects of your life where you might already know a lot about something, but there's some area that you wish you knew a little bit more about. And you can really use that to leverage into some confidence to help you make a pivot in your professional life. And don't discount the experience that you have and the value of that. Because context, like I said, I bang this drum a lot, and it's not just self-serving. Context really matters. And when you're talking with leadership, if you can't convince them that you understand their business problems, you understand their context, they're not going to use your tool. And that's a really important piece that we bring to the table with our experience. So, package up the imposter syndrome, set it aside. It's something that I'm still learning to do myself. I'm not going to say that I'm super good at this already. But I would consider those other aspects of your life where, maybe you already know a lot, you could learn a little bit more. If you can leverage that confidence over to your professional life, that'll help you be successful.